Hello. In this video we'll be discussing the Pythagorean Theorem, how it's proven, and how we can use the Pythagorean Theorem to find the lengths of sides on a right triangle. We do an informal proof of the Pythagorean Theorem by starting off with a larger square, inside of which we draw a smaller square. The edge length of the larger square is the sum of two numbers a and b, whereas the edge length of the smaller square is c. Notice that the figure contains four congruent right triangles. To get the area of the smaller square, we take the area of the larger square and subtract from it 4 times the area of each of those right triangles. The area of the larger square is the quantity a plus b squared, whereas the area of each of those triangles is the product 1/2 ab. Since the edge length of the smaller square is c, we know that its area is c squared. Now, we already have an expression for the area of the smaller square, so we can write an equation that takes that expression and sets it equal to c squared. I'll show you that equation and the steps we can take to simplify that equation to complete our proof of the Pythagorean theorem. Okay, so now we have the Pythagorean theorem. Great, but what does it mean? If we look at the figure we used to prove the Pythagorean theorem, that figure contains four congruent right triangles. Pulling up one of those right triangles next to the Pythagorean theorem, we see that A and B represent the lengths of the legs of the right triangle, and C is the length of the hypotenuse. So what the Pythagorean theorem then is really saying is that if we take the sum of the squares of the legs, that sum is equal to the square of the hypotenuse. Now that we know what the Pythagorean theorem is, we'll use it on a few examples to gain some meaningful information about figures that contain right triangles. In this first example, we'll be looking at a right triangle whose legs have measures of 3 and 4, and we're going to find out the length of the hypotenuse using the Pythagorean theorem. I'll show you step by step how this works. In the previous example, we solved for the length of the hypotenuse of a right triangle. In this next example, we'll solve for the length of one of the legs. Well, those last two examples were relatively simple examples of the application of the Pythagorean theorem. The next example will be somewhat more complex, but nonetheless will involve the use of the Pythagorean theorem in order to solve it. As you can see, this problem has a lot of moving parts. Ultimately, we're being asked to find the area of a rectangle, but all we're given specifically is the length of its diagonal. You may recall that to compute the area of a rectangle, we take the product of its length times its width. We don't have those, but what we do have are expressions for the length and the width in terms of the variable x. That means that before we can do anything else, we better find out what x is. We can use the Pythagorean theorem to generate an equation containing x. I'll give you that equation, and I'll simplify it a little bit. So as you can see, the resulting equation is a quadratic equation. That means then that we would use quadratic equation methods in order to solve it. I'll show you the steps to do that. Now that we know what x is, we can find out what the length and the width is, and then ultimately find the area of the rectangle. This concludes our discussion of the Pythagorean Theorem. If you're interested in high-quality math tutoring, or if you want to check out more videos like this one, log on to www.themathking.com. Thanks for watching.